Good day. For those of you who don't know me, my name is Douglas Harder, and in this topic, we're going to give an overview of Brent's method. So in this topic, we will review the Brent-Dekker method, we'll introduce Brent's method for minimization, and describe the algorithm at a very high level. Now, recall the Brent-Dekker method for finding a root of a real valued function of a real variable. This is a root finding technique that alternates between the bisection method, the bracketed secant method, and the inverse quadratic interpolation method. Now, the first of these three methods has the strongest guarantees of convergence. With every single step, we are guaranteed that the width of the interval will be dropped by a factor of 1/2. The last, however, has potentially the greatest rate of convergence under ideal conditions. So the Brent-Dekker algorithm prefers the technique where that technique appears to be converging, but if necessary, it will revert to one of the first two if the conditions seem to be unfavorable. Now, Brent, in his 1973 text, Algorithms for Minimization Without Derivatives, he details an algorithm that alternates using the golden ratio search and successive parabolic interpolation. Now, as you can see, it does use the golden ratio search. So this algorithm assumes that we have bracketed a minimum. It's actually a very useful book and still quite readable. It describes some interesting characteristics of minimization, including the issue that even though technically a minimum may exist and it may actually be unique, due to floating point computation, you may actually not have a very simple, smooth minima. So he delves into interesting detail in his chapters discussing the problems with finding minima of real valued functions of a real variable and the issues with floating point numbers. Now, Brent's method starts with the golden ratio search, and the way it's designed actually applies it twice. After this, it tries to use successive parabolic interpolation to continue from that point forward. Now, it continues to use successive parabolic interpolation. However, under certain conditions, it will revert back to the golden ratio search. So, for example, if after 2 steps of successive parabolic interpolation, if the step size has not dropped by at least, or the width has not dropped by at least half, then it reverts to golden ratio search. After all, you will recall that with 2 steps of the golden ratio search, this reduces the width of the interval by a factor of phi to the exponent -2. And so this is approximately a factor of 0.381966. So if successive parabolic interpolation cannot do better than golden ratio search, it reverts back to the golden ratio search. Now, fortunately, Brent's text is available online for free at the author's website, and it's available as a downloadable PDF. You are welcome to search for and download this text for your own personal reading and enjoyment. The end of chapter 5 actually has an implementation of the algorithm we've just described in the Algol 60 programming language. Now, you're more than welcome to translate this into C++ or any other language of your choice. Now, one interesting feature about this is that this is another algorithm that has been written in the last half century. What that means is this is an algorithm that's been written at least within the lifetime of your grandparents, if not your parents. Also, Brent's method is the basis in MATLAB for the function fminbound, and that the information about that function is available at this website. You can, of course, also view the source code for this by looking at the source file fminbound.m. So following this topic, you are now aware of Brent's method. You understand that algorithms like this exist and are available, and they try to go for the best of both worlds. They use a more efficient algorithm when it appears to be converging, successive parabolic interpolation, but revert to guaranteed convergence algorithms such as the golden ratio search when the more efficient technique appears to be not converging. You're also aware that the text is available for your reference. Here are the references, acknowledgements, the colophon, and a disclaimer. Cheers!